is Santosh. I'm part of the infra solutioning team from IBM. So next couple of minutes, what we are going to see is the role of IBM. The role of infra systems in this next phase of industrial revolution. So the manufacturing industry, by the nature of the industry, if you see, I mean, what is the objective always? I mean, to drive more and more production scale, to do it with the least amount of time, and then to get the optimum desired result which is expected. So to do that, to achieve that, what is important is kind of every minutest detail is observed. I mean, right from the sourcing of the material to the assembly in the production line, to the supply chain stage, to the delivery of the final product to the customer and getting his feedback. So what does it result into? It results into a lot of devices, lot of sensors, lot of trackers, lot of data which is captured, and then which requires a lot of applications to interpret data and get a meaningful information out of it. And then finally, you require different kinds of data storages, storing methodologies. So if you kind of look at your data center now, it's kind of transforming. So at one end you have your systems of engagement, which is all your end user devices, your IoT enabled trackers, sensors, your customer feedback from web, and then you have the systems of record, which is your core ERP kind of workload, and then you have the systems of insight, which kind of gathers all this data and gives you a meaningful chart or meaningful representation of all this data. And then you have a lot of new age applications, a lot of new age ways of storing this data in form of a private cloud solution or a public cloud solution or a hybrid solution. So this huge amount of data requires a totally different way of interpreting and finally giving you a meaningful result, which requires kind of new age applications. So a lot of open source applications are coming in which kind of interpret this data. And from the hardware perspective, if you see, so what we have to do is to appeal to this open new age applications. From the hardware perspective, from the compute perspective, what we have to do is we have to open up our processing architecture so that these ecosystems, these ISPs can kind of use this processes technology to build their own custom processes and kind of have the most optimized source codes for this to leverage the processor innovations. So what we have come up with is a ecosystem called as Open Power Foundation, where we collaborate with all these ISPs and application providers to build the most optimally performing applications. So these are a couple of examples of the collaborations which we are having with the ISP ecosystems. And then from the processor innovation point of view, what we have to do is we have to see you are able to do more with less, as in you are able to kind of crunch more transactions, more operations with lesser and lesser amount of cores. So we are moving our processor generation gradually, bringing in new processor innovations from Power 7 to the current generation, which is Power 8, and then working on Power 9 as well. So, and coming to when we are talking about manufacturing, so the heart of any manufacturing industry is ERP, and one of the SAP is one of the leading ERP vendors which is ruling the roost. So now SAP also is kind of taking a dynamically different approach of handling this data. So what does it say? I mean, it says traditionally when you have different kind of data stores, what we are going to do is we are going to consolidate all these data stores. And then traditionally when you are trying to have a business logic in your application layer, and then when you require some data, you used to go to your database layer. Now what we are going to do is we are going to reverse it. What we are going to do is load all the amount of data which is available into the memory, which is high speed access area, and then do all the logic and crunching over there, and then pass fewer data to the application layer, which kind of avoids the system bottleneck and gives you better performance. With which what they are able to do is, they are able to do real-time OLTP, they are able to do real-time analytics. So they are saying, let's have one database per landscape. So let's have one database for production, be it ERP or a CRM or a APO or a SRM or BI. Let's have one database for development, and kind of make everything real time. So the way this can be achieved is through a step-by-step process, which is like your traditional R3 ERP, which you are moving to suit on Hana, which is kind of you are swapping your existing database with Hana database, and then to the next stage, which is bringing in the application S4 Hana business logic as well at the application layer. So what is actually required to deliver this performance from the infrastructure side? So SAP HANA says, so this is a very performance hungry application. So the benefits which they show that can be really leveraged if you have the best hardware architecture with you. When you say best, the best possible clock frequency, the best possible cache hierarchy, the best possible bandwidth, memory and I/O, the most robust processor architecture, and a deployment model which is really scalable and flexible, and then a reliable platform. So why does IBM become a natural platform choice for this kind of workload? So if we see, our journey in our HANA journey, we started in 2015 second half, and in the next 1.5 years, which is end of this chart captures the data till last year end. So we were able to acquire 500 clients in 1.5 years, and majority of them were competitive takeouts. And why were we able to do that? Because of 3 key factors which we really focused on. First thing is the flexibility of your HANA deployment. Second is the resiliency of our power systems platform. Third is the performance which we are able to deliver on our platform. So if we kind of go deep dive into each of the sections, so when we say flexibility, now HANA, in a lot of your landscapes would be kind of new. So you try to do something, but you will not be having a complete picture of it. So tomorrow, maybe 1 year later, you want to do make some changes to it. But if you don't have a flexibly deployable model, then you will be kind of constrained with the hardware you have purchased. So, so what is different in power systems architecture? So power systems architecture, the crux of it is a virtualization engine. So the virtualization engine which power systems offer is a Power VM hypervisor, which is kind of a zero overhead hypervisor. So which kind of helps you host more workloads on lesser compute resources. Then you have a lot of intelligent workload management features like CPU donating, sharing, then increase and decrease of CPUs dynamically without a downtime, and couple of highly innovative solutions like a shared processor pool wherein you kind of club multiple natured workloads so that you can handle unseen peaks without the system getting suffered or your users getting affected. So that is on the flexibility part. And second is, how many HANA production instances are you able to fit in one physical system? Why is it important? This kind of demonstrates how robust your architecture is, how is a testimonial in to say that this platform architecture stands out from the rest. So when SAP Note kind of SAP directly certifies that your IBM Power Systems can kind of run 8 production systems, HANA production systems in one physical hardware. Whereas for any other competitive solution, it says you cannot do more than 1. 8 versus 1. So there obviously has to be a difference which SAP sees in the hardware architecture, because of which they kind of give this kind of certification. And third, in terms of flexibility, is right from day one, we have always advocated for a tailored data center integration approach. So what we are saying is, now when you're moving to HANA, you don't throw away your existing, you have made an investment in your existing data center, right? You have bought compute, you have bought storage, you have bought, invested in SAN switches, LAN switches. So wherever possible, wherever SAP allows it, please reuse it for your HANA solution. And then on top of that, you can buy extra compute and extra storage to get your, to build your HANA solution. Whereas competition started with the appliance model because because of various reasons, and then but finally they moved to with a TDI approach which IBM had been advocating from day one. So appliance model was kind of a closed knit architecture where you give this much code, this much memory and do whatever you want to do, and it's a very rigid, you cannot do anything beyond that. So if for some reason you are not able to plan it initially, you kind of have to, your 3 years hardware which you bought goes to waste. You again have to invest in new hardware. In that way, a TDI approach gives you a highly customizable solution. And then a second point is a resiliency. Now, the power systems architecture was built ground up to deliver you the maximum highest possible RAS available. So it wasn't like, okay, we saw this particular feature from the competition and we are trying to play a catch game and we include that RAS feature into our processor architecture. So power systems architecture is built on mainframe architecture, and it kind of has a host of reliability, availability, serviceability features right from your virtualization layer to your hardware, to your processor, to your memory, to your I/O, and each and every part of your system. It doesn't talk about only the processor like our competition does. Okay, this particular processor is having this much, these and all features, because what matters to your application is your end-to-end system performance. This is why third-party consultancies like ITIC rates IBM power systems kind of number one in terms of the server reliability which we are able to deliver, the virtualization and reliable virtualization engine which we offer, the security which we are able to offer in our hardware, and the lowest unplanned downtime. And third and most important is the performance part. Now so all those glizzy features of SAP HANA comes to zero if you don't have a properly, highly performing hardware, underlying hardware. So what does kind of determine the performance of a hardware? If you start from ground, it's the processing threads, it's the processing cache hierarchy, it's the bandwidth which is available from a processor to the memory to the I/O, and all these things. So compared to competition, we have always led the performance charts, because of the basics which we are able to do better in terms of giving more 4 times better threads, 4 times better bandwidth, and almost 5 times more cache on our processor architecture, because of which we are able to almost give the number one SAP's benchmarking results which SAP publishes. So as a reference, you can also go through this IDC white paper, which kind of, there are 2 white papers. One white paper talks about how important it is to have a platform of choice, as an alternate platform of choice, because initially when HANA was rolled out, it was available only for Intel. It wasn't available on power systems. So that was when, and when it was first time certified on power systems in 2015 Q2, IDC had published that white paper saying how different this platform is for your SAP HANA workload. And this is one more follow-up white paper they had published. So this is kind of the end of my chart. So as a closing remark, what I would like to say is, hardware really matters a lot. Your next 5 years roadmap, like was being mentioned earlier, you need to focus to buy on the best possible hardware infrastructure systems, which kind of gives you the best performance, the most reliable RAS features, and gives you the flexibility to deploy your HANA workloads.